Okay, for this video, I would like to talk about energy change in reactions and the fact that all of these compounds we're talking about contain energy, and that energy is stored in the bond. And so the idea, if I have something like sodium bonded to chlorine, that line represents the bond. That bond is where the energy is. Or if I've got something like water, that bond is where the energy is. And that's the piece we're interested in. Our bodies need energy, and so our bodies get that energy from the chemical bonds that exist. And so here, breaking bonds requires energy. So think of food in your stomach. You put all that hamburger, that chicken, that salad, that apple, the carrot, you ate that food, it's in your stomach. Well, now your stomach has to break a whole bunch of chemical bonds in order to break that food down. Well, that requires energy. Energy has to go in. That's like paying for something when you go to the store. Going to the store and buying something that requires money. You have to give money away. Our body has to give energy to our stomach to get that to happen. Forming bonds releases energy. The best example I can give here with the money, if you go to the casino, which unfortunately you guys can't, but if you play a game and you win a bunch of money, all the coins come out, that would kind of be that idea. So not the greatest analogy, but that's kind of the idea, that idea of releasing energy, or that slot machine releasing money. So it's the best I got for you. But now forming bonds releases energy. So here, these two are separate, sodium plus chlorine. Now there's a bond formed. When that bond forms, energy is released. So breaking bonds requires the use of energy, and forming bonds releases energy. And we can do two things with this, you guys. We have exothermic reactions and endothermic reactions. Exoskeletons. Exo means outer, so think like a crayfish, a crab, a lobster. They have that hard shell on the outside. That's because their skeleton is on the outside of their body. That's just where it exists. And so exothermic energy is released. And so think lighting a match. How many of you have burned yourself at a campfire, at a match, on a stove? All that heat is being released, and it absorbs into your finger and you get burned, or wherever the case may be, maybe whatever part of your body. So the energy required to break the bonds of the reactants is less than the energy released as the products form. Here, many of you have used these things, these portable hot pads. How many of you this time of year in the wintertime take them when you go skiing? You open them up, there's a chemical reaction that occurs in there, and that reaction releases heat. Luckily, it's releasing that heat really slowly. It's not like a match or a campfire where it's huge quantities of heat, because then you'd get burned. This is an exothermic reaction that slowly releases heat. Put them in your boots. Put them in your gloves. If you're sitting on the ice fishing, put them in your butt pockets for all I care. Go to a football game on a metal bleacher, put them in your butt pockets. But many of you have used those hot hands, and like I said, put them in your boots, put them in your pockets, put them in your mittens. Put them in pockets in your coat, and they'll help keep you warm because they slowly release energy. Hunting and skiing and all snowmobiling, all sorts of outdoor winter activities that people would use those for. But bottom line, it's just a creative use of an exothermic reaction. The other type of reaction is endothermic. Endo, in or inner. You and I as humans, we have an endoskeleton, and that means our skeleton is on the inside. So crabs and lobsters have an exoskeleton. You and I as humans, we have an endoskeleton. Mammals, all sorts of organisms have endoskeletons. Ours are on the inside. Well, this is heat going in. And so that heat goes in. To cook those eggs, we have to add heat to them. To melt that ice, heat has to go in. These cold packs, and again, a lot of you have used these before. The idea with those cold packs, there's a reaction that occurs there, and it needs heat. And so what you do with it, you activate that ice pack by breaking the inside pouch, and then that reaction starts to occur. And it's a very cold reaction because it's pulling in heat. And so maybe you sprained an ankle sliding into home plate. Who knows what it was? Maybe you were pitching in the game and your shoulder's really sore. So you use a portable ice pack and you set it on your shoulder, your wrist, your elbow, wherever the soreness is. And that body part starts to get cold. Why is it getting cold? Because that cold pack is absorbing heat. And since it's absorbing heat from your body starts to feel cold. So that heat is moving in. So exothermic reaction, that heat's moving out. It's trying to get out of there. Endothermic, it's trying to move in. So we got to think of the direction that heat is flowing. Is it going in or out?